Introduction. Computer networking is the practice of connecting computers together to enable communication and data exchange between them. In general, computer network is a collection of two or more computers. It helps users to communicate more easily. Basic technologies of computer network. Network. A network is a collection of computers and devices that are connected together to enable communication and data exchange. Nodes. Nodes are devices that are connected to a network. These can include computers, servers, printers, routers, switches, and other devices. Protocol. A protocol is a set of rules and standards that govern how data is transmitted over a network. Examples of protocols include TCP/IP, HTTP, and FTP. Topology. Network topology refers to the physical and logical arrangement of nodes on a network. The common network topologies include bus, star, ring, mesh, and tree. Service provider networks. These types of networks give permission to take network capacity and functionality on lease from the provider. Service provider networks include wireless communication, data carriers, etc. IP address. An IP address is a unique numerical identifier that is assigned to every device on a network. IP addresses are used to identify devices and enable communication between them. DNS. The domain name system (DNS) is a protocol that is used to translate human-readable domain names such as www.google.com into IP addresses that computers can understand. Firewall. A firewall is a security device that is used to monitor and control incoming and outgoing network traffic. Firewalls are used to protect networks from unauthorized access and other security threats. Types of enterprise computer networks. LAN. A local area network is a network that covers a small area, such as an office or a home. LANs are typically used to connect computers and other devices within a building or a campus. WAN. A wide area network is a network that covers a large geographic area, such as a city, country, or even the entire world. WANs are used to connect LANs together and are typically used for long-distance communication. Cloud networks. Cloud networks can be visualized with a wide area network as they can be hosted on public or private cloud service providers, and cloud networks are available if there is a demand. Cloud networks consist of virtual routers, firewalls, etc. Open system. A system that is connected to the network and is ready for communication. Closed system. A system that is not connected to the network and can be communicated with. Types of computer network architecture. Computer network falls under these broad categories. Client-server architecture. Client-server architecture is a type of computer network architecture in which nodes can be servers or clients. Here, the server node can manage the client node behavior. Peer-to-peer architecture. In P2P architecture, there is not any concept of a central server. Each device is free for working as either client or network devices. An interconnection of multiple devices, also known as hosts, that are connected using multiple paths for the purpose of sending, receiving data or media. Computer networks can also include multiple devices/mediums which help in the communication between two different devices. These are known as network devices and include things such as routers, switches, hubs, and network topology. The network topology is the layout arrangement of the different devices in a network. Common examples include bus, star, mesh, ring, and daisy chain. OSI model, Open System Interconnection. OSI stands for Open System Interconnection. It is a reference model that specifies the standards for communication protocols and also the functionalities of each layer. The OSI has been developed by the International Organization for Standardization, and it is seven-layer architecture. Each layer of OSI has different functions and each layer has to follow different protocols. The seven layers are as follows. Number 1. Physical layer. Number 2, data link layer. Number 3, network layer. 4, transport layer. 5, session layer. 6, presentation layer. 7, application layer. Physical layer. The physical layer is the bottommost layer in the open system interconnection model, which is a physical and electrical representation of the system. It consists of various network components such as power plugs, connectors, receivers, cable types, etc. The physical layer sends data bits from one device, like a computer, to another devices. The physical layer defines the type of encoding, that is, how the zeros and ones are encoded in a signal. The physical layer is responsible for the communication of the unstructured raw data streams over a physical. This is the diagram showing how this works. Functions performed by physical layer. The following are some important and basic functions that are performed by the physical layer of the OSI model. Number 1. The physical layer maintains the data rate, how many bits a sender can send per second. 2. It performs the synchronization of bits. 3. It helps in transmission medium decisions, direction of data transfer. 4. It helps in physical topology, mesh, stack, bus, ring decision, topology through which we can connect the device with each other. 5. It helps in providing physical medium and interface decision. 6. It provides two types of configuration point and multi-point configuration. Provides an interface between devices like PCs, computers, and transmission medium. It has a protocol data unit in bits, hubs, Ethernet, etc. devices used in this layer. This layer comes under the category of hardware layers, since the hardware layer is responsible for all the physical connection establishment and processing too. It provides an important aspect called modulation, which is the process of converting the data into radio waves by adding the information to an electrical or optical nerve signal. It also provides a switching mechanism wherein data packets can be forwarded from one port, sender port, to the leading destination port. Physical topologies. Physical topology or network topology is a geographical representation of linking devices. Following are the four types of physical topology. Mesh topology. In a mesh topology, each and every device should have a dedicated point-to-point connection with each and every other device in the network. Here, there is more security of data because there is dedicated point-to-point connection between two devices. Mesh topology is difficult to install because it is more complex. 2. Star topology. In a star topology, the device should have a dedicated point-to-point connection with a central controller or hub. Star topology is easy to install and reconnect as compared to mesh topology. Star topology does not have the fault tolerance technique. Bus topology. In a bus topology, multiple devices are connected through a single cable that is known as backbone cable with the help of tap and drop lines. It is less costly as compared to mesh topology and star topology. Reconnection and reinstallation are difficult. Ring topology. In a ring topology, each device is connected with repeaters in a same circle like ring. That's why it is called ring topology. In ring topology, a device can send the data only when it has token. Without a token, no device can send the data, and the token is placed by a monitor in a ring topology. Line configuration, point-to-point configuration. In a point-to-point configuration, there is a line link that is fully dedicated to carrying the data between two devices. Multi-point configuration. In a multi-point configuration, there is a link line through which multiple devices are connected. Walkie-talkie, railway track, etc. Full duplex mode. In this mode, both devices can send and receive the data simultaneously. Examples: telephone systems, chatting applications, etc. Physical layer protocols. Example: technically, a combination of hardware and software programming makes up the physical layer. It consists of several protocols that control data transmissions on a network. The following are some examples of layer 1 protocols. Data link layer. The data link layer is the second layer from the bottom in the OSI network architecture model. It is responsible for the node-to-node delivery of data. Its major role is to ensure error-free transmission of information. DLL is also responsible to encode, decode, and organize the outgoing and incoming data. This is considered the most complex layer of the OSI model as it hides all the underlying complexities of the hardware from the other above layer. Sublayers of data link layer. The data link layer is further divided into two sublayers which are as follows. Logical link control (LLC). This sublayer of the data link layer deals with multiplexing the flow of data among applications and other services. An LLC is responsible for providing error messages and acknowledgements as well. Media access control (MAC). MAC sublayer manages the device's interaction, responsible for addressing frames, and also controls physical media access. The data link layer receives the information in the form of packets from the network layer. It divides packets into frames and sends those frames bit by bit to the underlying physical layer. Functions of the data link layer can be seen over here. Number 1. Framing. The packet received from the network layer is known as a frame in the data link layer. At the sender side, the DLL receives packets from the network layer and divides them into small frames, then sends each frame bit by bit to the physical layer. It also attaches some special bits for error control and addressing at the header and at the end of the frame. At the receiver's end, DLL takes bits from the physical layer, organizes them into the frame, and sends them back to the network layer. Second, addressing. The data link layer encapsulates the source and destination's MAC address/physical address in the header of each frame to ensure node-to-node delivery. MAC address is the unique hardware address that is assigned to the device while managing error control. Data can corrupted Data can get corrupted due to various reasons like noise, attenuation, etc. So it is the responsibility of the data link layer to detect the error in the transmitted data and correct it using error detection and correction techniques respectively. DLL adds error detection bits into the frame's header so that receiver can check received data is correct or not. Flow control. If the receiver's receiving speed is lower than the sender's sending speed, this can lead to an overflow in the receiver's buffer and some frames may get lost. So it is the responsibility of DLL to synchronize the sender's and receiver's speed and establish flow control between them. 5. Access control. When multiple devices share the same communication channel, there is a high probability of collision. So it's the responsibility of DLL to check which device has control over the channel, and DSMA/CD and CSMA/CA can be used to avoid collisions and loss of frames in the channel. Network layer services, packetizing, routing, and forwarding. The network layer is the third layer in the OSI model of computer networks. Its main function is to transfer network packets from the source to the destination. It is involved both the source host and the destination host. At the source, it accepts a packet from the transport layer, encapsulates it in a datagram, and then delivers the packet to the data link layer so that it can further be sent to the receiver. At the destination, the datagram is decapsulated and the packet is extracted and delivered to the corresponding transport layer. Features of network layer. The main responsibility of the network layer is to carry the data packets from the source to the destination without changing or using them. Second, if the packets are too large for delivery, they are fragmented, that is broken down into smaller packets. Third, it decides the route to be taken by the packet to travel from the source to the destination among the multiple routes available in a network, also called routing. 4. The source and destination addresses are added to the data packets inside the network layer. Services offered by network layer. The services which are offered by the network layer protocol are as follows: packetizing, routing, and forwarding. Packetizing, the process of encapsulating the data received from the upper layers of the network, also called payload, in a network layer packet at the source and decapsulating the payload from the network layer packet at the destination is known as packetizing. The source host adds a header that contains the source and destination address and some other relevant information required by the network layer protocol to the payload received from the upper layer protocol and delivers the packet to the data link layer. The destination host receives the network layer packet from its data link layer, decapsulates the packet, and delivers the payload to the corresponding upper layer protocol. The routers in the path are not allowed to change either the source or the destination address. The routers in the path are not allowed to decapsulate the packets they receive unless they need to be fragmented. Routing. Routing is the process of moving data from one device to the another device. These are two other devices offered by the network layer. In a network, there are a number of routes available from the source to the destination. The network layer specifies some strategies which find out the best possible route. This process is referred to as routing. There are a number of routing protocols that are used in this process, and they should be run to help the routers coordinate with each other and help in establishing communication throughout the network. Third, forwarding. Forwarding is simply defined as the action applied by each router when a packet arrives at one of its interfaces. When a router receives a packet from one of its attached networks, it needs to forward the packet to another attached network, unicast routing, or to some attached networks. In case of multicast routing, routers are used on the networks for forwarding a packet from the local network to the remote network. So the process of routing involves packet forwarding from an entry interface out to an exit interface. Difference between routing and forwarding. Routing. Routing is the process of moving data from one device to another device, whereas forwarding is simply defined as the action applied by each router when a packet arrives at one of its interfaces. Routing operates on the network layer. Forwarding operates at the network layer. Word is based on forwarding table. Forwarding checks the forwarding table and work according to that. Routing works on protocols like Routing Information Protocol (RIP) for routing. Forwarding works on protocols like UDP encapsulating security payload. Other services expected from network layer. Error control. Although it can be implemented in the network layer, it is usually not preferred because the data packet in a network layer may be fragmented at each router, which makes error checking inefficient in the network layer. Flow control. It regulates the amount of data a source can send without overloading the receiver. If the source produces data at a very faster rate than the receiver can consume it, the receiver will be overloaded with data. To control the flow of data, the receiver should send feedback to the sender to inform the latter that it is overloaded with data. There is a lack of flow control in the design of the network layer. It does not directly provide any flow control. The datagrams are sent by the sender when they are ready, without any attention to the readiness of the receiver. Congestion control. Congestion occurs when the number of datagrams sent by the source is beyond the capacity of the network or routers. This is another issue in the network layer protocol. If congestion continues, sometimes a situation may arise where the system collapses and no datagrams are delivered. Although congestion control is indirectly implemented in the network layer, still there is a lack of congestion control in the network. Advantages of network layer service. Packetization service in the network layer provides ease of transportation of the data packets. Packetization also eliminates single point of failure in data communication system. Routers present in the network layer reduces network traffic by creating collision and broadcast domains. With the help of forwarding, data packets are transferred from one place to another in the network. Disadvantages of network layer services. There is a lack of flow of control in the design of the network layer. Congestion occurs sometimes due to the presence of too many datagrams in a network that is beyond the capacity of the network or the routers. Due to this, some routers may drop some of the datagrams and some important pieces of information may be lost. Although indirect error control is present in the network layer, there is a lack of proper error control mechanisms, as due to the presence of fragmented data packets, error control becomes difficult to implement. Transport layer responsibilities. The transport layer is the second layer in the TCP/IP model and the fourth layer in the OSI model. It is an end-to-end layer used to deliver messages to a host. It is termed an end-to-end layer because it provides a point-to-point connection rather than hop-to-hop between the source host and destination host to deliver their services reliably. The unit of data encapsulation in the transport layer is a segment. Working of transport layer. The transport layer takes service from the application layer and provides services to the network layer. At the sender's side, the transport layer receives data message from the application layer and then performs segmentation, divides the actual message into segments, adds the source and destination's port numbers into the header of the segment, and transfers the message to the network layer. At the receiver side, the transport layer receives data from the network layer, reassembles the segmented data, reads its header, identifies the port number, and forwards the message to the appropriate port in the application. Responsibilities of a transport layer: the process-to-process delivery, end-to-end connection between hosts, multiplexing and demultiplexing, congestion control, data integrity and error correction, and flow control. Process-to-process delivery. While data link layer requires the MAC address, 48 bits address contained inside the network interface card of every host machine of source destination host to correctly deliver a frame, and the network layer requires the IP address for appropriate routing of packets. In a similar way, transport layer requires a port number to correctly deliver the segments of data to the correct process amongst the multiple processes running on a particular host. A port number is a 16-bit address used to identify any client-server program. End-to-end connection between hosts. The transport layer is also responsible for creating the end-to-end connection between hosts, for which it mainly uses TCP and UDP. TCP is a secure connection-oriented protocol that uses a handshake protocol to establish a robust connection between two end hosts. TCP ensures the reliable delivery of messages and is used in various applications. UDP, on the other hand, is a stateless and unreliable protocol that ensures best effort delivery. It is suitable for applications that have little concern with flow or error control and requires sending the bulk of data like video conferencing. It is often used in multicasting protocols. Multiplexing and demultiplexing. Multiplexing many-to-one is when data is acquired from several processes from the sender and merged into one packet along with headers and sent as a single packet. Multiplexing allows the simultaneous use of different processes over a network that is running on a host. The processes are differentiated by their port numbers. Similarly, demultiplexing one-to-many is required at the receiver side when the message is distributed into different processes. Transport receives the segments of data from the network layer, distributes and delivers it to the appropriate process running on the receiver's machine. Congestion control. Congestion is a situation in which too many sources over a network attempt to send data and the router buffers start overflowing, due to which loss of packets occurs. As a result, the retransmission of packets from the sources increases the congestion further. In this situation, the transport layer provides congestion control in different ways. It uses open-loop congestion control to prevent congestion and closed-loop congestion control to remove the congestion in a network once it occurred. TCP provides AIMD, additive increase, multiplicative decrease, and leaky bucket technique for congestion control. Data integrity and error correction. The transport layer checks for errors in the messages coming from the application layer by using error detection codes and computing checksums. It checks whether the received data is not corrupted and uses the ACK and NACK services to inform the sender if the data has arrived or not, and checks for the integrity. Flow control. The transport layer provides a flow control mechanism between the adjacent layer of the TCP/IP model. TCP also prevents data loss due to a fast sender and slow receiver by imposing some flow control techniques. It uses the method of sliding window protocol, which is accomplished by the receiver by sending a window back to the sender informing the size of the data it can receive. Section layer in OSI model. The section layer is the fifth layer in the Open System Interconnection (OSI) model. This layer allows users on different machines to establish active communication sessions between them. It is responsible for establishing, maintaining, synchronizing, terminating sessions between end-user applications. In session layer, streams of data are received and further marked, which is then resynchronized properly, so that the ends of the messages are not cut initially and further data loss is avoided. This layer basically establishes a connection between the session entities. This layer handles and manipulates data which it received from the session layer as well as from the presentation layer. Working of session layer. Session layer, which is the fifth layer in the OSI model, uses the services provided by the transport layer, enables applications to establish and maintain sessions and to synchronize the sessions. Now, in order to establish a session connection, several things should be followed. First thing is we should map the session address to the shipping address. The second thing is that we need to select the required transport quality of service, also referred as QoS, parameters. Next thing is we need to take care of the negotiations which should happen between session parameters. Then we further need to transmit limited transparent user data. Then at last we need to monitor data transfer phase properly. The ability to send larger amount of data files is extremely important and a necessary thing too. Presentation layer in OSI model. Presentation layer is the sixth layer in the Open System Interconnection model. This layer is also known as translation layer, as this layer serves as a data translator for the network. The data which this layer receives from the application layer is extracted and manipulated here as per the required format to transmit over the network. The main responsibility of this layer is to provide or define the data format and encryption. The presentation layer is also called as syntax layer since it is responsible for maintaining the proper syntax of the data which it either receives or transmits to the other layers. Functions of presentation layer. Data from application layer goes to presentation layer, goes to data from session layer. Presentation layer, being the sixth layer in the OSI model, performs several types of functions which are described below. Presentation layer format and encrypts data to be sent across the network. This layer takes care that the data is sent in such a way that the receiver will understand the information, data, and will be able to use the data efficiently and effectively. This layer manages the abstract data structures and allows high-level data structures, example banking records, which are to be defined or exchanged. This layer carries out the encryption at the transmitter and decryption at the receiver. This layer carries out data compression to reduce the bandwidth of the data to be transmitted. The primary goal of the data compression is to reduce the number of bits which is to be transmitted. This layer is responsible for interoperability, ability of computers to exchange and make use of information between encoding methods as different computers use different encoding methods. This layer basically deals with the presentation part of the data. Presentation layer carries out the data compression, number of bits reduction while transmission, which in turn improves the data throughput. This layer also deals with the issues of a string representation. Presentation layer is also responsible for integrating all the formats into a standardized format for efficient and effective communication. This layer encodes the message from the user-dependent format to the common format and vice versa for communication between dissimilar systems. This layer deals with the syntax and semantics of the messages. This layer also ensures that the messages which are to be presented to the upper as well as the lower layer should be standardized as well as in an accurate format too. Presentation layer is also responsible for translation, formatting, and delivery of information for processing or display. This layer also performs serialization process for translating a data structure or an object into a format that can be stored or transmitted easily. Features of presentation layer in the OSI model. Presentation layer, being the sixth layer in the OSI model, plays a vital role while communication is taking place between two devices in a network. List of features which are provided by the presentation layer are: presentation layer could apply certain sophisticated compression techniques, so fewer bytes of data are required to represent the information when it is sent over the network. If two or more devices are communicating over an encrypted connection, then this presentation layer is responsible for adding encryption on the sender's end as well as the decoding the encryption on the receiver's end so that it can represent the application layer with unencrypted, readable data. This layer formats and encrypts data to be sent over a network, providing freedom from compatibility problems. This presentation layer also negotiates the transfer syntax. This presentation layer is also responsible for compressing data it receives from the application layer before delivering it to the session layer, which is the fifth layer in the OSI model, and thus improves the speed as well as the efficiency of communication by minimizing the amount of data to be transferred. Presentation layer protocols. Presentation layer, being the sixth layer but the most important layer in the OSI model, performs several types of functionalities, which makes sure that data which is being transferred or received should be accurate or clear to all the devices which are there in a closed network. Presentation layer, for performing translations or other specified functions, needs to use certain protocols which are defined below. Apple Filing Protocol is the proprietary network protocol communications protocol that offers services to Mac OS or the classic Mac OS. This is basically the network file control protocol specifically designed for Mac-based platforms. Lightweight Presentation Protocol (LPP). Lightweight Presentation Protocol is that protocol which is used to provide ISO presentation services on the top of TCP/IP based protocol stacks. Network Core Protocol (NCP). Network Core Protocol is the network protocol which is used to access file, print, directory, clock synchronization, messaging, remote command execution, and other network service functions. Network Data Representation (NDR). Network data representation is basically the implementation of the presentation layer in the OSI model, which provides or defines various primitive data types, constructed data types, and also several types of data representations. External Data Representation (XDR). External Data Representation (XDR) is the standard for the description and encoding of data. It is useful for transferring data between computer architectures and has been used to communicate data between very diverse machines. Converting from local representations to XDR is called encoding, whereas converting XDR into local representation is called decoding. Secure Socket Layer (SSL). The Secure Socket Layer protocol provides security to the data that is being transferred between the web browser and the server. SSL encrypts the link between a web server and a browser, which ensures that all data passed between them remains private and free from attacks. Application layer in OSI model. The application layer is topmost layer in the open system interconnection model. This layer provides several ways for manipulating the data information which actually enables any type of user to access network with ease. This layer also makes a request to its bottom layer, which is presentation layer, for receiving various types of information from it. The application layer interface directly interacts with the application and provides common web application services. This layer is basically highest level of open system which provides services directly for application process. Functions of application layer. The application layer, as discussed above, being topmost layer in OSI model, performs several kind of functions which are requirement in any kind of application or communication process. Following our list of functions which are performed by application layer of OSI model. Data from user goes to application layer, goes to data from presentation layer. Application layer provides a facility by which users can forward several emails, and it also provides a storage facility. This layer allows users to access, retrieve, and manage files in a remote computer. It allows users to log on as a remote host. This layer provides access to global information about various services. This layer provides services which include email, transferring files, distributing results to the users, directory services, network resources, and so on. It provides protocols that allow software to send and receive information and present meaningful data to users. It handles issues such as network transparency, resource allocation, and so on. This layer serves as a window for users and application processes to access network service. Application layer is basically not a function, but it performs application layer functions. The application layer is actually an abstraction layer that specifies the shared protocols and interface methods used by hosts in a communication network. Application layer helps us to identify communication partners and synchronizing communication. This layer allows users to interact with other software applications. In this layer, data is in visual form, which makes users truly understand data rather than remembering or visualize the data in the binary format zeros or ones. This application layer basically interacts with operating system OS and thus further preserves the data in a suitable manner. This layer also receives and preserves data from its previous layer, which is presentation layer, which carries in itself the syntax and semantics of the information transmitted. The protocols which are used in this application layer depend upon what information users wish to send or receive. This application layer is generally performs host initialization followed by remote login to host. Working of application layer in the OSI model. In the OSI model, this application layer is narrower in the scope. The application layer in the OSI model generally acts only like the interface which is responsible for communicating with host-based and user-facing applications. This is, this is in contrast with TCP/IP protocol, wherein the layers below the application layer, which is session layer and presentation layer, are clubbed together and form a simple single layer, which is responsible for performing the functions, which includes controlling the dialogues between computers, establishing as well as maintaining, as well as ending a particular session, providing data compression and data encryption, and so on. Features provided by application layer protocols. To ensure smooth communication, application layer protocols are implemented the same on source host and destination host. The following are some of the features which are provided by application layer protocols. The application layer protocol defines process for both parties which are involved in communication. These protocols define the type of message being sent or received from any site, either source host or destination host. These protocols also define basic syntax of the message being forwarded or retrieved. These protocols define the way to send a message and the expected response. These protocols also define interaction with the next level. The application layer provides several protocols which allow any software to easily send and receive information and present meaningful data to its users. The following are some of the protocols which are provided by the application layer. Telnet. Telnet stands for Telecommunication Network. This protocol is used for managing files over the Internet. It allows the Telnet clients to access the resources of Telnet server. Telnet uses port number 23. DNS. DNS stands for Domain Name System. The Domain Name System service translates the domain name selected by user into the corresponding IP address. For example, if you choose the domain name as www.abcd.com, then DNS must translate it as 192.36.20.8, random IP address written just for understanding purposes. DNS protocol uses the port number 53. DHCP. DHCP stands for Dynamic Host Configuration Protocol. It provides IP addresses to host. Whenever a host tries to register for an IP address with the DHCP server provides lots of information to the corresponding host. DHCP uses port number 67 and 68. FTP. FTP stands for File Transfer Protocol. This protocol helps to transfer different files from one device to another. FTP promotes sharing of files via remote computer devices with reliable, efficient data transfer. FTP uses port number 20 for data access and port number 21 for data control. SMTP. SMTP stands for Simple Mail Transfer Protocol. It is used to transfer electronic mail from one user to another user. SMTP is used by end users to send emails with ease. SMTP uses port number 25 and 587. HTTP. HTTP stands for Hypertext Transfer Protocol. It is the foundation of the World Wide Web (WWW). HTTP works on the client-server model. This protocol is used for transmitting hypermedia documents like HTML. This protocol was designed particularly for the communications between the web browsers and the web servers. But this protocol can also be used for several other purposes. HTTP is a stateless protocol, network protocol in which a client sends requests to server and server responses back as per the given state, which means the server is not responsible for maintaining the previous client's request. HTTP uses port number 80. NFS. NFS stands for Network File System. This protocol allows remote hosts to mount files over a network and interact with those file systems as though they are mounted locally. NFS uses the port number 2049. SNMP. SNMP stands for Simple Network Management Protocol. This protocol gathers data by polling the served devices from the network to the management station at fixed or random intervals, requiring them to disclose certain information. SNMP uses port numbers 161 TCP and 162 UDP. Thank you.